mean? Does anybody know the symbol for mean when we're talking about a sample? It's actually X bar. X bar, that symbol tells you to find the mean. And the mean is just the average of the data. So X bar is referred to as X bar. Yeah. And that is the symbol for the average of a sample. We also have the population, and that would be mu. And mu is the average of the population versus X bar is the average of the sample. Now, generally, we're dealing with a sample.
Is that M?
No, it's the Greek symbol mu. Mu. Okay. All right. So, now you guys know how to find the average. Add them up, divide by how many there are. Okay. So let's get used to the symbolism. X bar. Add them up. What symbol means add them up in math? The sum. Sigma. Good. Okay? So the capital sigma means sum. All right? That means add them up. To find the sum of all the pieces of data. And what we represent all the pieces of data is exabyte. Our entire data set. And then we divide it by how many pieces of data we have. Well, n represents the number of pieces of data, n.
Okay. I thought we were doing math. Yeah, this is just like physics. I don't like it.
This is Greek.
Mythology. Who says that?
All right, median. Median, the symbol for median is an n. Okay, median. And it represents the middle number of an ordered data set. Now, generally, it's least to greatest, but it could be greatest to least because the median is the middle. If there's not exactly one piece of data in the middle, if there's an even number in our data set, you would take the two pieces of data that lie in the middle and average them. And that's how we would find the median. And the mode. The mode is the value that occurs most often in a data set. Now, the mode is actually most useful in describing categorical variables. So, we can have categorical variables that are not numeric, or that actually are numeric but are really categories. So, if you think about clothing sizes, let's say you go to a store and you're picking out a shirt. Small, medium, large, extra small, extra large, whatever. Those are categories. And we could find the one that's sold most often. That would be the mode, right? So if medium was most often, that would be it. Or we could talk about gentlemen and their pant sizes. So we could have like, I don't know, where do y'all start? 24, 25, 26, 27?
On what? Waist?
Waist, yes.
32.
You are not a 32.
On waist?
Really?
I'm like a 32.
I'm like a
You
30.
seem quite trim.
I'm like a 33.
Okay. All right. So maybe I started a little low. Even though they are numeric, they actually represent different categories in this case. It's not continuous data. All right. So here's a data set. Now, when I give you a data set such as this one, and there's no information with the data set, it's not in context of a problem. When we look at this data, we consider this to be all of the data. Well, that would be the entire population. Versus, on tonight's homework, number 23 on tonight's homework talks about the scores on the first 13 games. Well, that's not all the games. So that's not the entire population. That's a sample. So first you have to differentiate, am I dealing with a sample? Is this data set a sample? Or does this data set represent the entire population? Well, if there's no information given with it, we assume it's the entire population. So if I just give you a data set out of context, boom, here's a data set. we assume that's the entire population. All right, so I want you to find the mean, median, and mode of this data set. Use your calculator. We are definitely using technology. We need the calculators out anyway, so pull them out.
Let's turn ahead.
And then,
Wait, what are we doing with that? We're turning it in for like.
No, usually we do.
Yeah, I lost them.
Yeah.
I left your note.
I don't know.
all right, I don't want a lot of whining and talking and stuff. If you don't have a calculator, have a couple to borrow today. Make sure you bring yours.
Chase, would you just turn it in?
Caroline needs
Okay, cool. Alright.
Wait, didn't you already grade that?
Find the mean, median, mode.
Did you not already grade that?
Okay, that was like 20 minutes ago.
Oh my god.
It's fine.
Like you? I mean, I'm already
Every time.
I have some of the work done about sheet.
Turn that in.
Okay, but not all of it's on here. You were on the worksheet, I'm on the worksheet.
Okay. Because we said that was going to be due when we met last week, and then we didn't meet last week. So, see if you can find it and turn it in tomorrow. But turn in what you have today, please. If you have credit for your homework, then you should be fine. I did check all the reviews of those people that turned them in. All right, so the mean, you should have gotten 81.57. The median is the middle number when listed from least to greatest or greatest to least. So we have to order the numbers and then look for what's in the middle. So when we order the numbers, you should have noticed that 83 lies in the middle of the data. And so 83 would be our median. 83. Now the mode is the number that occurs most often, and for this data set, the mode would be 84. Now, which measure of central tendency? Now, we call these measures of central tendency because we're describing where the center of the data tends to be. And we have different ways to describe that. That's what the mean, median, and mode are. There are 3 different ways to describe the center of the data. Now, with your grade in this class, what do? I average, so I do the mean. Now, there are some teachers that drop your lowest grade.
You should do that.
And then they do the mean. But in this case, we just do the mean. Now, give an example of when you would use the mode to describe a data set. That's when we would have some type of categories. It's usually when the data is categorized or categorical. Now, the mean is affected by really high values and really low values. It can be pulled one direction or the other, and we're going to talk about that more in depth tomorrow. But the median is not so much. So sometimes you'll see data when it talks about the median score of the data is this. And when we look at the median, it is not affected by really high values or really low values. The median is not affected by extreme values, and sometimes we refer to those as outliers. So if we were gonna try to represent average salaries in Fayette County, and we randomly selected a few people, and one of them happened to be like a multimillionaire, what would that do to our data? It would pull that mean up really high, wouldn't it? It would skew our data. So a lot of times when you look at data, and you guys might do this when you're choosing a place to live, you might look at the median household income. And so that would describe what the middle person in that area would look like. Okay? And so sometimes the median isn't affected by those really high or really low values. Yes, sir? Did you say something? Chase? I thought you said something. No? Okay. All right. Now, let's move this out of the way. The next thing we're going to look at is a different type of measure. We talked about where's the center of the data lie. Another measure is to describe how the data varies. How far apart is the data? And we have a couple ways to do that. The first way that you learned was in elementary school. You learned about range. The range of a data set is the highest value minus the lowest value. The greatest minus the least. The max minus the min. That's range. And range does give us an indication about how far apart the data is spread. But when we're comparing data sets, the range isn't always so helpful, and we'll see that in just a moment. The next one is called IQR. Do you guys remember doing box and whisker plots?
Yes.
Yeah, so we're going to revisit those in just a minute. But IQR is interquartile range. And the interquartile range also helps describe how far apart the data is spread. And the way we find that is we take the Q3 and we subtract Q1 from it. The third quartile minus the first quartile. We'll revisit that in a minute so that makes sense. Now, quartile, what does that make you think of? Quarters. Okay? So that's what, when we look at the data and we're talking about quartiles, we're dividing the data up into 25% here, 25% here, 25% here, and 25% there. That's what a box and whiskers does. And we'll look at that in a minute. So we're going to do that Q3 minus the Q1. Now, the new one for this year is variance and standard deviation. Now, variance is an important statistic, and it would be used if you're really doing some serious analysis on your data. Now, this unit, we're just dipping our toes in the water. We're getting some basic knowledge about statistics. So we have a little bit of basic knowledge. We're not really using variance in here because the variance helps us know what kind of test we would need to run on our data. And we're not going that far with it. So what we're going to focus on is standard deviation. And we actually have two types of standard deviation. The formula printed here is the first one we're going to discuss, and this is the most commonly used because this standard deviation is what we would do for standard deviation of a sample. And when we're doing statistics, we're looking at samples. So this is what we use for a sample. And when we look on our calculator a minute, this is denoted by S and then the X. The standard deviation of a sample. So that's what standard deviation of a sample. This is the formula. You find the difference between each piece of data and the mean of the data set. We square that. We add up all of those. You divide it by the number of pieces of data minus 1 when it's a sample, and then you take the square root of it. Now, generally our data sets are pretty large. We would like to have at least 30 pieces of data, and we'll talk about that in a little while. So when we have a fairly large data set, if we were to do this by hand, this would leave us a lot of room for error. So we're going to do it on the calculator. We're going to use technology because anytime you do statistics in the real world, we're using technology. We're either running programs that do this statistics, we're using Excel. We're going to use the calculators because that's what we have at our disposal here. So the first type of standard deviation is for a sample. The other one would be for the entire population. And if we had the entire population, the formula wouldn't change very much. Instead of dividing by n minus 1, you just divide by n. We don't have to allow room for error because we don't have a sample. So it would look like this. Okay, so on the calculator, when we analyze our data, this would give us our standard deviation. The lowercase sigma. Lowercase sigma.
Is it supposed to be square root or divide?
This is a square root symbol. Yeah.
That one.
Yeah. Square root.
What's the name? I'm sorry. To the left.
This.
No. Like right
This is a lowercase sigma, and sigma represents standard deviation of a population. So, if I gave you an entire data set, this is the one you'd look at. If it were a sample of data, a sample from the data set, then this is what we would look at on our calculator. All right, so now we're going to remind ourselves how to enter data on our calculator, because we have entered data on our calculator before. We entered data to do linear regression. We entered data to do quadratic regression. We did analyze data on our calculator earlier, but you may not remember, so I'm going to teach it like you've never done it before. All right, so everybody get out your graphing calculators.
Oh, I wasn't done.
Okay.
Really, Sam? Dude. I'm almost done already. Just give me like one more second. Is it down here? Yeah. Okay, I'm done.
Okay.
Thanks.
All right. So the first thing we're going to all do is press the stat button. Press the stat button. Okay. And we're going to edit our data list. So hit enter for edit. Now, I have data in my list that I want to get rid of. Okay, so to get rid of data, you arrow up until you have highlighted the label for that column, and you hit clear and enter, and it all goes away. Now, sometimes we forget directions, and we might arrow up there and go, okay, I want it to go away. Let's hit delete and enter.
Then you're messed up.
Then we're messed up because the whole column went away. So if you accidentally delete a column, it's real easy to get it back. To get a column back, if you accidentally delete it, you hit the stat button and choice 5. Choice 5 and enter. And then you go back into stat and you'll see that L1 is back. So if you open up your calculator and you don't have what you want there, do the setup editor and you'll get back all your columns. Okay, so let's enter our data, and we're going to use that data set from the top of the page. So let's enter 70, 84, 78, 90, 84, 82, 83. Okay. Now, we're going to perform statistics on this data now. So if you hit the stat button again, we're going to calculate those statistics. So hit stat and arrow over to calc. We have one column of data. It's not multivariable, it's just single. So one variable stats, so we'll hit enter. And I put my list in L1. If I had put it in L2, do y'all see if I did blue button and then 2, it would change that to L2? Is it dead? Oh, that's somebody in here, probably.
Come on, bro. Yeah, I'm just looking at Nate's right now. Mine doesn't have a stat.
So we go to stat and we go to what?
Okay, stat, arrow over to calc, and enter, enter, enter.
Wait, what did you do after you hit enter?
I hit stat,
Yeah.
I arrowed over to calc, and I hit enter, 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 enter.
So the one.
Alright, now, do y'all see we got the same mean that we calculated by hand just a moment ago? Now, that's what X bar represents, mean. Yes, sir?
How do you use the which one?
Dollar.
Alright.
I'm gonna make it.
Okay, so X bar is the average. Now, the next one says sigma X. What does the capital sigma mean?
Sum of.
The sum of. So that's the sum of all of our data. So if you needed to add it up, that's what it is. This is the sum of the squares of the data. Now, SX. That is the sample standard deviation. So the sample standard deviation for this set of data is this. The population is next. Okay? Sigma X. This is the population standard deviation. Now, N. N represents how many pieces of data I entered. I entered 7 different pieces of data. And then what we get to is really cool. It's the min, the Q1, the median, the Q3, and the max. The min, Q1, median, Q3, and the max. 5-number summary, guys. That was the 5-number summary that we used to create our box and whiskers. And you guys have already done that. So it gives you all this data. So if we arrow down, we can see the min, Q1, the median, the Q3, and the max. Okay, so S, this is the standard deviation for the sample. This is the sample standard deviation. Okay, this is the population standard deviation. Okay. Where did mine? There it is. There it is. Sample, population. Got it? All right. So if it's in context of a problem and we can tell it's a sample, we would use the sample standard deviation. If it's just a data set I give you, you would use the population standard deviation. And that's how we're going to differentiate between those. So we have to determine, is it a sample? Is it the entire population? Okay, on the back, we have 2 data sets here, and we're going to practice. I want you guys to find both the sample and the population standard deviation. Girls, I would like you to do data set 1. Gentlemen, excuse me, ladies, data set 1. Gentlemen, data set 2. Okay? 1 and 2. You're undecided. You can do 1 and 2.
Classic.
It's like gender and you're like other.
That is practice.
Thanks.
You're welcome.
Actually,
Darren, as soon as you're done.
stat.
You want us to write it all down?
We're gonna write down. I'm gonna write down both of them in just a sec. So set 1.
2, 3.
I am. I sure am.
Do you know how to box?
Yeah. It's okay. That's not a big deal.
I forgot what button to click after I put all of the numbers in.
Is it like the up button? Stat 5.
Arrow over calc. And then one variable stat. Enter, enter, enter. There you go.
Wait, I'm erroring the what?
So once you write it,
Population.
So there's an example one down the bottom right of your page.
I forget how to do that. I just started trying to do it. But I'm not. What?
Yep. You take the men, you draw a line from quartile 1, so we draw a box from quartile 1 to quartile 3. It's all just calculated.
Oh, I
Gone vision.
Okay. Data set 1.
No.
What'd you get for the sample standard deviation? If this data represented a sample, what would we say the standard deviation is? 7.239. Awesome. All right. What would the population standard deviation be? 6.608. Awesome. Okay, gentlemen. Set 2. What did you find the sample standard deviation to be? 10.991? Okay, and what about the population standard deviation? 10.03 what? 3? Okay. Alright, now, what this tells me is when I look at step 1, when we're talking about the standard deviation as a representation of the spread of the data, I can tell, looking at sample 1, that data in that sample is closer to the mean than it is in sample 2. Okay? Now, when I look at the range, though, when I look at the range of the data, greatest minus least, 24 minus 2 is 22. Greatest minus least, 24 minus 2 is 22. The range is also it describes the spread of the data. But if I just looked at the range, I think the data sets were pretty similar, wouldn't I? But when you look at the individual pieces of data, that shows in the standard deviation that they aren't as similar. All right. The IQR, the interquartile range. Where the range didn't show me much, the interquartile range will. So if we look at our calculators on data set 1, the interquartile range is Q3, IQR, is Q3 minus Q1. That third quartile minus the first quartile. And those of you that did data set 1, you will see that Q3 is 16 and Q1 is 10. So my IQR is 6. That tells me that 50% of the data lies within 6 units of each other. Now, this IQR, Q3 is 23, Q1 is 3, this is 20. Do you see how much larger? That tells you about the spread of the data. The data is further apart. Most of the data is further apart. Now, the median of this data, this median is 13, and this median is also 13. So if we were to go and create a box and whisker, let's do set 1, and I'm going to do set 2 in a different color. Okay, to do a box and whisker, the first thing we'll do is do dots for the min and max values. So set 1 has a min value of 2 and a max value of 24. Okay, and then we do lines for Q1, the median, and Q3. Q1 of data set 1 was 10. The median of both data sets is 13. And Q3 for data set 1 was 16. And so this is what our box looks like. And then here are our whiskers. Okay, so if you remember from when we first did box and whiskers, 25% of the data lies here, 25% of the data lies here, 25% of the data is here, and 25% of the data is here. That's why we call it quartiles, because it breaks it up into 4 different sections. Okay? Now, let's do set 2. We have the same min and max. We have the same median, but Q1 is here and Q3 is here. And that tells us a lot about our data. We can tell this data is not as close to the median as the other data. 50% of the data is pretty close. 50% of the data on the same exact scale is much further apart. Okay, so what do you notice about the box and whiskers? They have the same max and min, which means their range is the same. Okay, and they also have the same median. But where they differ is in their IQR and their standard deviation. Okay? Because the IQR and standard deviation are much greater in data set 2. And we can see that looking at the data. Okay, now, what are the means of each data set? They're both 13 also, aren't they? So if we just looked at the mean of the data, or we just looked at the median of the data, or we just looked at the range of the data, we think the data is very similar. But when we look at the IQR and the standard deviation, it tells us that there are differences in that data. Okay, so let's look at properties of standard deviation. When we look at standard deviation, it tells us how the data deviates from the mean. So the standard deviation is always going to be greater than or equal to 0. The only time it will equal 0, guys, is if every piece of data is the exact same number. So if every piece of data was the number 3, is there any differentiation from the mean? No, because they're all the same number. So the only time it's going to equal 0 is when all values are the same. That is the only time your standard deviation will equal 0. I don't think I've ever analyzed data where my standard deviation was 0. Now, when the standard deviation increases, this is going to increase as the data spreads further out from the mean. So it's going to be as the spread of the data about the mean increases. So the further the data is from the mean, the larger your standard deviation. Now, standard deviation, just like averages, can be strongly influenced strongly affected by outliers. So we have to find a way of determining outliers, and then sometimes when we do statistics, we will eliminate those outliers so they don't affect our data. Now, how do we find an outlier? An outlier is any data that exists below 1.5 times the IQR from Q1 or above 1.5 times the IQR from Q3. So if we were to enter this data set on our calculator, and I'm just going to give you the min of this data set is 10.2. Q1 of this data set, so if we had time to practice, you would just enter this data on your calculator, but I'm giving it to you. The median of this data set is 14.6. Q3, the third quartile, is 14.9. And the maximum piece of data is 16.4. So if you entered this data on your calculator, ran one variable statistics, the last 5 statistics you would get is this 5-number summary. The min, Q1, the median, Q3, and the max. That's what they are. So, IQR. IQR is Q3 minus Q1. In this case, 14.9 minus 14.4. So in this example, our interquartile range is 0.5. So to see if we have any outliers, we would do Q1 minus 1.5 IQR and see if any of the data lies below that. So in this case, it would be 14.4 minus 1.5 times 0.5. That value is 13.65. Do any pieces of data lie below that?
Yes.
Yes. So we have outliers. Or do any pieces of data lie above this? Q3 plus 1.5 IQR, which in this case would be 14.9 plus 1.5 times 0.5. Is there anything above 15.65? Yes. So we can define the following values as outliers. Anything that lies outside this range, if it lies outside these two values, either less than this or greater than that, it's considered an outlier. Those outliers for this particular problem are defined as 10.2, 15.9, and 16.4. If we graph the 5-number summary on our calculator, look what it does. This value is an outlier. This value is an outlier. This value is an outlier. Okay, your homework's out of your textbook. If you can't find your textbook, go online.
What?
Okay?
You have a textbook.
Yeah, you got one a long time ago. All right, access in.
What
Okay.
page is it on?
Your calendar will be posted online, but it's on page 11 of your textbook.